This is StarTalk, Cosmic Queries Edition. Neil deGrasse Tyson here, your personal astrophysicist. I got with me Paul Mecurio. Paul, welcome back to StarTalk.
All right, great to be back. Great to see you, buddy. How are you?
All right, Paul's a professional comedian. You're an Emmy, and I just learned also a Peabody Award winner. You never told me that. You get an Emmy just for being funny, but you get a Peabody Award for being funny with purpose.
With intellect.
With intellect.
Why are you laughing that I don't have an intellect?
No, I didn't know. That's not, no, that's not why.
I know.
No, just congratulations. I think Peabody, we've always counted that among the highest possible awards someone can get who's got stuff online or on TV or in video. So congratulations on that.
Thank you. Yeah.
And you perform regularly on The Late Show with Stephen Colbert. So we're great to have you here. So today it's Cosmic Queries, and we're going to talk about astrobiology. We don't talk about that subject enough. And so we're going to bring a returning guest, Kennda Lynch. Kennda, welcome back to StarTalk.
Hi, thanks so much for having me. I'm super excited to be here.
Excellent. You're a staff scientist at the Lunar and Planetary Institute, the LPI, just outside of Johnson Space Center in Planet Houston. And you're an astrobiologist, and we have you on primarily to talk about a new NASA project called Plant Trek. Now, we all know Star Trek. Plant Trek sounds a little derivative, but investigating strategies. I got the line here. Investigating strategies for regolith preconditioning to support establishment of plant microbe systems in Martian habitats.
I wrote that, by the way. I wrote that.
He did it in English.
You're welcome, Ken. You're welcome.
Oh, thank you, Paul. Thank you.
So, Ken, don't ever repeat that phrase on this show, ever. Okay? Now, what the hell is a regolith? I think I know, but it sounds like you've been hanging out with geologists too long. So let's give us in plain English what Plant Trek is and what your relationship is to the project.
What we're trying to do with Plant Trek is we're trying to figure out how to live on Mars and grow our own food on Mars using in-situ resources, or basically Martian regolith. We can't call it dirt or soil because it doesn't have microbes in it that we know of. So anything that doesn't have life in it is regolith, that we define in the geological terms as regolith. And so Martian...
Wait. So your roots are in biology, astronomy, or geology, or all of the above?
I wear a lot of hats. So my actual bachelor's degrees, I have two because I'm crazy, and I got two at University of Illinois at the same time. My bachelor's degrees are in engineering and biology, and I designed my secondary field in engineering to focus on what's called advanced life support systems. So back when I was doing engineering and I was an engineer, I learned about how to develop life support systems for astronauts. And back then we were talking about something called bioregenerative life support systems, or closed loop life support systems, ways to basically take Earth with us and recycle things, use plants to help us make air, help us clean our water.
Without needing a supply ship.
Without needing a supply ship or any kind of resupply, because relying on a 2-year turnaround for resupply from Earth is going to really suck if you're living on Mars. You don't want to have to do that. I mean, that's supply.
Okay, all right. Now these are tools and things. So how does astrobiology relate to this?
Well, that's an interesting thing that I discovered, and you asked about my relationship to it. I am the principal investigator. This is one of the projects that I got funded. Yes, I'm the PI. I got this funded with NASA to test this process that me and my colleagues came up with.
Wait. So you're PI. So yes. It is your fault that it has that title.
Yes, but we just call it Plant Trek, and yes, there's a T-shirt, and you should have my logo somewhere.
Listen, can I just propose this? I work at CBS. I think this is a drama. It's called Regolith PI, and then you show up.
Good one.
You got a shovel and a hat and a thing, and then there's a plant. We'll write regolith, it up.
So when I reach into the soils of Earth, I don't see it, but it is teeming with microbes that
millions and millions of microbes that have made that soil possible. Yes,
that enables plant life to grow in it.
Mm-hmm.
So if I go to the moon, I can still grab up a handful of dirt, or on Mars, but there's no microbes in it, so you don't call it dirt.
No, we don't call it Earth. We call it regolith because dirt, and we don't even, and if you talk to a soil scientist, they hate the D word. They don't like it called dirt. They like it to be soil. I've learned this from my colleagues who's the soil scientist.
The
So
D
it's
word.
soil.
Oh,
They call it the D word. I didn't know dirt was a 4-letter word, but apparently for this science it is.
Wow. Okay. So now what? So tell me how astrobiology fits in.
Well, astrobiology fits in because one of the things that we learned is that, Mars, what we know from all of our missions to both the moon and Mars is that the lunar regolith and the Martian regolith have a lot of interesting things in them. They have a lot of like heavy metals. They have a lot of iron. They have a lot of lunar soil has a lot of titanium. Martian soil has a lot of iron and sulfur. The big thing about Mars is we have a thing called perchlorate in it, and perchlorate is something that there's more of it in Martian regolith than there is on the highest site on Earth, which would be the Atacama Desert. And perchlorate is a really cool molecule that does cool things that we like to use it for spaceflight, like to build solid rocket engines.
Wait. The highest spot on Earth is Mount Everest. So what do you mean the Atacama
The
Desert?
highest concentration of perchlorate is in the Atacama Desert.
Highest, not the highest elevation.
Yeah, no, the highest concentration. I am sorry.
Because the Atacama Desert is a very high elevation. We have telescopes there for that reason.
Yes.
So that I was confused there. Okay, thank you for clarifying.
It is the highest concentration of perchlorate because it is one of the driest places on the planet. And perchlorate accumulates, natural perchlorate is raining actually all over the planet all the time. It's generated in the atmosphere using photochemistry with ozone. Photochemistry reactions with ozone make perchlorate, and it rains out all over the planet.
Wait. So what is the whole molecule? Perchlorate? It's got at least
perchlorate. It has got one little chlorine atom in the center, surrounded by 4 big oxygen atoms.
Oh, it's only chlorine and oxygen.
Mm-hmm.
I didn't know that. Okay.
Yeah, it's very simple.
Come on, Neil. Everybody knows that.
Come on, Neil.
I can't work like this, Lindsay. He's always. I'm sorry. He's always playing catch up on this stuff.
Okay. All right. So perchlorate. I got you. Mm-hmm. So ozone gets you 3 oxygen molecules for free. Okay. And so and how many total is surrounding the chlorine?
4. So 4 for perchlorate, and there's another one called chlorate. It's just 3, but we kind of focus on perchlorate right now because that's the big one that we care about the most right now.
And why is that important?
Because for a couple of reasons. First of all, it's important for humans because perchlorate is a contaminant that affects human health. Perchlorate is the perfect size to compete with iodine for binding on your thyroid. So if you have perchlorate in your system, it's going to knock that iodine out of the way and bind to your thyroid. And guess what? Your thyroid's not going to work too good.
Our bodies are just so stupid. They can't figure out what they don't know basic chemistry.
Right. So it's got the right affinity where it just likes to knock that iodine away. So if you're eating, let's say if you're eating Martian potatoes that were grown in Martian dirt, like Matt Damon did.
Matt Damon, right? Yeah.
And we didn't get rid of.
Those are poop potatoes.
They are poop potatoes, but remember, he planted them in the ground in Mars, an actual Mars regolith ground, which there would have been perchlorate in those regoliths. Even though he mixed it with poop, he didn't take care of the perchlorate. So if he had eaten those poop potatoes, other than the fact that they're poop potatoes, he would have been ingesting perchlorate like all the time because perchlorate is so mobile. It would have actually been uptaken probably into the potato. Bottom line is, if he'd eaten those potatoes, we would have killed Matt Damon.
Oh. Also, the idea that a group of people, in all seriousness, couldn't eat those potatoes because the poop has his pathogens in it, which would be fine for him, but wouldn't work for others.
Exactly.
Right?
There's some other issues with regards to the pathogenic
and I know this because as a hobby, I freeze dry my waste, just as a hobby. But the point is that, in all seriousness, it would not have worked as a concept, okay? Because
not without some bioremediation, which is one of the things that we try to do when we develop what we call biological life support, bioregenerative life support systems. We remediate things. We try to clean up things and make them safe before we use them to grow our food. And the first thing we're trying to do with Plant Trek is we're trying to deal with this big perchlorate elephant in the room, which is what do we do with the fact that there is up to 1%, in some cases 2% weight perchlorate in the Martian regolith. And if we're going to use that regolith to help us grow food, we need to figure out what to do with that perchlorate.
Wait. The moon is at least as dry as Mars. Why doesn't the moon have the same amount of perchlorate in it?
Well, that is a good question. It's probably because, first of all, the moon doesn't really have an atmosphere. And so perchlorate on Mars is probably also, there's a lot of chlorine on Mars because of all the volcanism on Mars. So there's a lot more
Okay.
chlorine on Mars. And there was a lot of,
Volcanism from long ago.
from
Not
long
going
ago,
on
but it
today.
still
Yeah.
put a lot of chlorine on there. And we're not sure if it's not quite the same process because there's not a lot of ozone on Mars, right? But we think it's more surface grain chemistry or other kind of chemistry, maybe even when there was surface or groundwater that made that perchlorate. Probably the biggest theory is probably surface type grain chemistry along with radiation like impacting it, causing like surface chemistry happening.
Radiation, you mean high energy light from the sun?
Yes, yeah, high
Yes,
energy
okay.
photons hitting.
Right,
So
all the
they-
high energy photons coming in.
Just
Yeah.
a quick question. There was an experiment done in China in laboratories with lunar soil where they grew a certain
This is not a
strain
quick question.
of certain sort of tobacco, and
Just a long question. Okay.
and then
go on.
is that tobacco? Was that experiment able? Is there any help that we've gotten from that for what you're doing in terms of what they used 3 forms of bacteria to grow this sort of strain of tobacco? Anything from that study that helps?
It does, because it's interesting, because there's a lot of different yes and no. So no on the fact that we're really not going to try to encourage tobacco use on the moon or Mars.
I
So,
know.
no.
I know. Paul,
So
where'd
not
you get
really
that news
for the
story?
for the type of plant that
Make-
they chose.
Nicotine addicts on Mars? What do you, Paul?
Right.
Well, listen, you're going to have a cigarette stand everywhere, so why not?
Paul.
But from the standpoint of that they tried different bacteria to try to improve the lunar regolith and to try to create a good community with the regolith, yes, that was very helpful. I've seen that study, and we're starting to move into some of the lunar regolith work too. But right now, one of our first things with Plant Trek and what we were funded to do is kind of solve that perchlorate issue. And the reason astrobiology ties in is because one of the things that I realized when I started thinking about life support systems with my colleagues again and things is that I learned so much about extreme environments and extreme microbes. And I actually happened to have this 2019 astrobiology paper where we discovered perchlorate reducing microbes in a Mars analog environment. We just happened to have that. And I was like, what if we took microbes from that environment and applied it to, and tested and see if we could take, Martian simulant that we preloaded with simulated with perchlorate, and we simulated actual Martian regolith. What if we took those bugs out of that environment and put them in Martian regolith to see if they could process all that perchlorate out? And hence Plant Trek was born.
This is a tiny part of the cog in the wheel of terraforming, isn't it?
You're using the T word.
The T word. I'm saying.
Oh my God.
If you want to make Mars good enough for prime time, you got to fix everything up.
Mm-hmm.
You need, and so you can put your microbes to work. You can have a microbe cocktail. You set it loose. Some will produce the ozone. Others will take out the perchlorate. Others will make the soil, whatever. Others will poop where you need it with the right kind of poop. Not Paul's poop. Paul's poop won't grow anything.
No,
So Neil, Neil, I'm glad you're getting excited, but I need to reel you in because we got this little thing called planetary protection. And we don't want to do that yet because we're still trying to find out if Mars has its own life on it. But we do want to be able to support human life. We don't want to kill our Matt Damons. We want to keep our Matt Damons alive. So we do want to try to figure out ways to use In-Situ resources because, like I said, that supply chain issue of 2 years, that's serious. It's even worse than the pandemic.
Also, you should stay in the character and call him Mark Watney. Okay, just so stay.
That's
I'm just saying. We've had Andy Weir as a guest on StarTalk, and he would want you to call him Mark Watney.
Fair enough, Mark Watney. We don't want to kill our Mark Watneys.
Introducing the all-electric Ford Mustang Mach-E SUV. Ford is electrifying its icons to keep the soul of driving alive while shifting towards an electric vehicle future. The Mustang Mach-E is an SUV with the bold style of a Mustang, which means you can make a bold statement and still be practical. The 2023 Mustang Mach-E GT Performance Edition SUV achieves 0 to 60 miles per hour in 3.5 seconds. It's an EV with exhilarating torque and available features like electric all-wheel drive and a drive mode called Unbridled. It has room for you, your people, and your things with 5 seats and a frunk, otherwise known as a front trunk. Experience the freedom and thrill of the drive while knowing your needs can still be met. Learn more about the all-electric Ford Mustang Mach-E SUV at ford.com/SUVs/Mach-E. Due to high demand and global supply chain constraints, some models, trims, and features may not be available or may be subject to change. Check with your local dealer for current information. For the 0 to 60 miles per hour in 3.5 seconds, Ford test data is based on a typical industry methodology using 1-foot rollout. Your results may vary.
So, Paul, this is a Cosmic Queries, and you've got questions for Kennda.
I do, yeah. We're going to jump right in here.
I haven't seen them. I don't think Kenda's seen them. And so,
No, I haven't seen a single thing.
So, Kennda, occasionally they drift into the universe. I'm happy to take those if it's like drifts away from your planet expertise. But otherwise, they're all for you. So let's go.
That works.
Well, this
Paul, what do you
first
have?
one's appropriate based on what we were just talking about. So this is from Dennis. Greetings, humans. This is Dennis from Indiana. Dr. Lynch, were you ever approached by filmmakers for technical support when they were shooting The Martian?
No, that's a good question. But no, I was still in grad school when they were shooting The Martian. So no.
Oh. Okay, but if they were shooting it today, no reason why you wouldn't be on their
Yeah,
list.
if they were shooting it today, I would give tech support any day of the week. That would be fun.
Yeah, but then you would have ruined the poop potato. Yeah, say that can't happen.
Cut. You would have had a big fight with Ridley Scott. There would have been a whole thing.
Right.
Just have a duke out with Ridley Scott. That's a dream.
Right, I'm just saying.
I gave technical advice on the movie on how to kill any living plant known to man ever. So I'm that guy. So I can't grow air plants. Okay, that's how bad I am.
I mean, they even skipped over the whole planetary protection issue about wondering about life on Mars. I mean, there were so many things astrobiology relevant.
Right.
They just skipped over. Yeah, but you know. You sit next to my friends who were both a planetary geologist and then a flight systems engineer when I went to go see the movie, and all of us were going, nope, on different parts of the movie. But we had fun. We thought it was fun. It was the closest movie that got close to accuracy on the science and the engineering. So we love it. We have fun. We loved it.
Science was its own character in that film.
It was. It really was.
I praise it for that. And Absolutely. That's the film where science became a verb.
There you go. I'm going to science the out of this.
I'm going to science the shit out of this, right?
There you go.
To science. That's what Matt Damon uttered in the film. Okay.
To science.
What else you got, Paul?
Okay. Andy Weber. Hey, Dr. Tyson, Dr. Lynch, and Dr. Mecurio. Wow. Thank you.
Oh, all right.
I just added that. This is Andy.
I was going to say he got an honorary PhD from.
Yeah, from the Daily Show. This is Andy from Edmonton, Alberta. I'm a big fan of the movie The Martian. And in that movie, Mark Watney, see, he did it, right? Is able to plant potatoes on Mars using Martian dirt, water, and human waste. Would this be possible? How could this be more realistic? Thank you so much. Love the show.
So let's unpack that. So we are told that solid excrement is fertilizer. There's an entire cottage industry in the farming universe for just that. So let me ask you, what's the difference between human poop and horse poop? All right, in terms of fertilizer. Second, what does the perchlorate matter if he's completely embedded the potato seeds or the eyes of the potato in poop? Then why does the rest of the perchlorate matter?
Well, so so let's unpack that completely. So first, the difference between perchlorate poop and like horse poop. Well, horses eat a lot more grass and a lot more like vegetarian diet, whereas humans tend to eat meat and other things. So
just get the poop of vegetarian humans. That's not line them up.
No matter what.
Do you know how annoying that poop would be? Oh my God! It'd be looking down its nose at the other poop. Oh, you're
everywhere from the vegetarian. No, that's the vegan poop that would.
Oh, that's true. Right.
The vegan poop.
Ooh. Well, of course, percolate is a problem for you because you're not a vegan poop.
So how do you make the Mark Watney scenario work? I think in the end, that's what we really want to know.
I mean, so how we make the scenario work is how we do things here on Earth. We add a few more things in between the poop and the plants that make the whole loop, right? So we get the plant, we get the poop, and we process it a little bit. We get the right microbes eating it, that microbes that are making things that we like nitrates and things like that we want to put in the soil. We get that in there, and then we can then turn and we make sure we get rid of the microbes, the bugs that could make people sick or like could kill are helpful bugs, because there are unhelpful bugs that could take over.
Yeah.
And we don't want that. So we want to make sure that we have a good microbial, we want to make sure we have a good poop microbiome.
Well, just because this microbe will do task A and this microbe will do task B doesn't mean A plus B will work, because A could eat B, is what you're saying.
Well, yeah, and we want to make sure that we have a good population of A through Z that are going to be happy and keep, like, if A is the bad guy that could really make a human sick, we want A under control. A is always going to be there. I mean, like, for example, E. coli is everywhere.
You know the kindergarten joke, why was 6 afraid of 7?
because 7, 8, 9.
Yes, because 7, 8, 9. That's like safe for kindergarten. Right.
Yes.
If you got microbes, you don't want microbes eating other microbes if they all have a task.
Or just taking over and taking all the resources. What they do is they may not eat the other microbe, but they may be like, see all these resources, they're all mine. And then they deny it from the other microbes, and the other microbes die of starvation. So you don't want that.
You can't genetically modify some of these microbes to make them what you want them to be?
We can, but we can, and there are folks that work on that. We're trying to, but microbes are pretty smart. Every time we think we got microbes understood, they go, yeah, here, hold my beer, watch this. So every time we think we got them understood, but they're pretty smart and they know how to organize themselves in a way to be optimal for the environment they're in. So we're trying to learn, at least on Plant Trek, we're trying to learn how microbes from an extreme environment, like, how could they organize themselves in a Mars simulated environment? How could they organize themselves to deal with perchlorate in a simulated environment? So that's what we want to try to do.
Okay.
So
right.
To get back to this unpack question is, yeah, we want to use that poop. That poop is good. It's got nutrients. We just want to make sure that we control. We get the rough guys under control, and we put them back in. And then we want to make sure. And the reason that the perchlorate still matters is, if you saw, Mark Watney still put the potatoes in the ground where that regolith still had perchlorate in it. And perchlorate is super mobile. It goes wherever water is. It's really water soluble. So you put in water, it's wherever the water goes, it's going to go. So if you water your potatoes and there is perchlorate in the regolith, it's going to dissolve into the water, and it's going to get uptaken by the roots of the potatoes and then get concentrated in the potatoes. So you don't want that.
And I just reminded myself of the periodic table of elements, where elements that appear in a vertical column have similar external similar electron configurations in their outermost shell, which means they make similar families of molecules to each other. So, and iodine is right there below chlorine in their column.
Exactly.
So wherever iodine goes, chlorine can go, and there you have it. Right.
And that's why they have the similar affinities, and that's why it can just kind of go, excuse me, iodine, boop, and knock it out of the way.
Right.
And we don't want that, because then you're going to be hypothyroid, and you're going to be tired and lethargic, and then things are going to be bad. You can generate heart disease if you have low thyroid. There's a lot of negative effects of low thyroid, and if you have chronically low thyroid, it can lead to really bad stuff, including the big D word.
Dirt. Stop. Okay. We can't have 2 D words in one show that are different.
Too much.
Stick with one D word, okay?
Fair enough.
Okay.
Are there any insects that translate to Mars that we can use, like insects here that could sort
It's got microbes. If you have microbes, you don't need insects.
Yeah, right.
Yeah,
Microbes.
Hugely macroscopic objects that are, microbes will do everything for you, right?
Well,
Kennda?
Ideally, right now we're kind of focusing on microbes. I mean, and insects are again, it's another type of things like insects, or on Earth, earthworms are very much a part of soil, right? But we have, and there are those that have worked on trying to add earthworms to like lunar and Martian regolith, but it takes a lot of work to keep them alive, and you have to add them a little later after you've kind of already pre-processed the regolith with like microbes first, but then you can eventually add like earthworms and things like that to the regolith to kind of help them get that regolith going into soil, right?
Yeah,
but
again, that's part of the part of the terraforming. I'm telling you.
But let's just
the T word.
We're going to keep it in the habitat for now. We're going to try to keep it in the habitat so that astrobiologists can still look for life on Mars outside the habitat.
Right. All right.
We're going to try to keep it in the habitat for now.
So, Paul, give me more.
Yeah, this is the artist formerly known as James Smith. Hello, all. James from Indianapolis here. So, Kennda, in the movie Arrival, what do you think the best course of action would have been had they given someone with your knowledge and background when the aliens showed up? Thanks. Have a great day.
Okay, so there are 2 Arrival movies. One of them had Charlie Sheen. I think it was
Right.
back in the 90s. And that I think they probably mean the more recent one, where the aliens put these vertical ships around the world. And then they got a physicist and a linguist.
Mm-hmm. They did.
And I would have picked, and I tweeted this, and I got jumped all over because first, social media is a cesspool. Second, how often do linguists ever get portrayed in movies? Right? Yeah. I said instead of a linguist and a physicist, they should have had an astrobiologist and a cryptographer. That's what I said. All right, but then I felt bad because give the linguist some cut them instead of casting shade on the linguist. So what would you have done in that case?
Well, as a scientist with astrobiology cred, I would have said, let me go take samples and listen to the linguist. They're figuring something out.
Wait, take samples? You'd go up to the septipod and then say, excuse me, let me cut some of your flesh away so I can analyze it in my lab.
You just do a little swab.
Can I just swab one of your tentacles? That's all I would have done. Is can I swab your tentacles? That's all I would have done.
Open the side of your head, and I want to swab.
Swab.
I just would want to. Yeah, that's all I want to do.
Or give me some of that ink or whatever you're drawing with, right? How about that? Okay.
Or just swab the spaceship. I would have just taken some spots of the spaceship and just.
Yeah, for those who didn't see the film, aliens arrived in these pods all around the world. I don't know how many locations there were, and we focused on the one that landed in the United States. There might have been several in the United States. I don't remember. And of course, the military is there and they've got to cordon it off. And we learn that these aliens, to them, time is a loop rather than a linear thing. And so and they play with your head about that, about events that happen either before or after. But if time is a loop, there is no before or after. There just is.
Right.
And so that's where they tried to take that.
Yeah. Well, and they did a lot of interesting thing about there was other underlying message about common language and commonness and understanding and communication being key, which when we're talking about searching for intelligent life, which is something we do in astrobiology, we look for technosignatures. We try to look for signs of intelligent life either in the past, especially if we're getting signatures from hundreds of light years away. We know that happened, in the past. That civilization may not be there anymore. But and we try to look for any kind of signs of like technosignatures, even I would say nearby, but not. They actually for the first time commissioned that committee on what is it? UAEs, unexplained events.
Aerial.
UAPs,
unexplained aerial phenomena.
You're right. So we're actually starting to think about, from a policy perspective, maybe we're not alone anymore, so maybe people are starting to think about that from that perspective. And that is something that we do have astrobiologists that think about that. So like I said, I would have been all about getting samples and trying to understand their microbiome or their genetics or lack thereof. Like, what are they made of? How did they come to be?
So here we are talking about swabbing the alien so we can study it. Whereas in the film Nope, which was like an alien horror film, basically.
Yes!
The alien is sucking people up from Earth. And while it never says it explicitly, it's pretty clear they're getting eaten.
It's a giant jellyfish kind of thing, just eating it and like digesting them.
And digesting you while you're in its digestive canal. And so in that case, it is swabbing us. Just
taste it, taking a little taste, and at certain things it didn't like, it would spit back out.
Spit back out.
But it begs the question. It answers the question that we are not alone in the universe. There are other humans, because if they like humans and that's what they eat, how did they survive until they got to us to eat us, right? So they had to be eating.
They were just unhappy campers eating lesser food. That's all.
They chicken or fish, they didn't care. They'd go either way.
Or deer, wolves, bears,
whatever.
They're too gamey. Humans are nice and plump.
Well, they were eating horses for a while. It seemed like in the show. They were eating a lot of horses.
I love that Kennda would just go into the ship and just start like getting samples from people.
And it's like.
And they'd be like, see, this is why the humans are a little bit annoying. They just come right in and they just take over, as opposed to like at least chit-chatting for a minute before you start taking swabs.
I kind of liken myself to Grace from Avatar. Like, she's like, I need to get samples wherever she is.
Right. If you're a scientist,
yeah.
There's a fun science comic where someone, connects these two electrodes and there's a spark, and they get shocked, and they said, boy, I'm never doing that again. And then another person comes up, connects them, they get sparked, and said, wow, I wonder if that happens every time. That's the scientist. Paul, keep going.
All right. This is Captain James Riley. Season's greetings from Houston. I was wondering what percentage of Mars soil, regolith rock, is seeming to work best in your soil mixes for healthy plants, and what kind of composition are we dealing with Mars rock powder? I suppose you won't have to supplement iron.
Really good question. And let me just add to that Kennda, remind me, which mission intentionally landed at the boundary between the receding ice cap and Phoenix mission, the Phoenix mission. So that one is finding Martian regolith soils that are damp, and maybe there's some action there.
Yeah.
Right.
Well,
so that's a place. That's a place. And the captain duly noted that Mars has way more iron than the moon does, right? And which gives it its rusty color, I think, right?
Yeah, because it gets oxidized from that. Like I said, that radiation, like the surface is very oxidized because of the heavy, radiation particles and things like that. That's where we get that red color from the iron.
Solar wind.
Yeah.
Okay.
So it's from that. Yes.
Okay.
It's a great Frank Sinatra movie, by the way, Buzz song, by the way, Frank Solar Wind. But anyway, go ahead. Continue.
So to answer this question, great question. And that's the beautiful thing, is that Martian regolith has so many beautiful things that we love. It has that iron, so we don't need iron. It has sulfur. It actually has, it has a little bit of organic carbon, but it also has carbonates. It has a little bit of nitrates, like biologically available nitrogen is nitrate. Not a lot, but it has nitrogen in its atmosphere, which is good. We have a lot of other elements. We have some phosphorus. We have all these other elements that we need, and it does have a little bit of oxygen.
What do we do with phosphorus? Because my first encounter with phosphorus was like phosphorus bombs, right? And so we need phosphorus for our health. What is it doing in our body?
It's the part of the DNA backbone. The phosphate backbone is fundamental to the creation of DNA.
Stupid.
Okay. Okay. So now I'm caught up. I'm all caught up now.
So if someone says you have no backbone, they're saying you have no phosphate. That's what they're saying.
Yeah, your phosphorus depleted.
Depleted, yeah.
I got you.
So yeah, it has a lot of the different. It has like the chnomps or sponge. It has like a lot of the different things. It has hydrogen. It has all of those things. From a mineralogical standpoint, from the actual regolith, like the rock, it's in the rock. We have lots of clay. We like clay in Earth. We actually have clay in Earth, and because clay helps do a lot of things. Clay has activated surfaces, so it lets things bind to it, and it does cation exchange. Cation exchange is very important in soil for plant growth. Clay absorbs water. It can hang on to water, so it can, clays swell when they have water, so they're very good for water retention in the soil, so that water, so we don't have overwatering and we don't drown our plants, but then we have an access to water that the plants can take for a period of time. And then we also have and believe it or not, and I'm still not quite sure why this works, I'm assuming it's the calcium, but gypsum. There's actually here on Earth, they actually, to help certain soils, certain plots of agriculture improve their growth yield, they will actually like go out and lay out gypsum and add and supplement the gypsum. I think it has something to do with the calcium supplementation and the calcium and the sulfate. And the sulfate probably gets used by microbes, but the calcium is an essential element that the plants need. And so those two minerals are two things that we have in abundance on Mars.
and remind me, gypsum is that the softest item on that hardness scale?
You know what? I don't remember my mineralogy very well because I didn't take it officially. I'm a just-in-time learner. I learned my mineralogy on my
own. If you don't remember that, why is anything you say, we should take anything you say seriously?
Because I do have degrees in biology and engineering.
There you go.
And environmental microbiology.
Time for just a couple more. Yeah, let's see what we can squeeze in.
Mary Lee Dewey. This is the subject I've been waiting for. I'm a high school biology teacher, and this discussion comes up a lot. We've been studying the Miller-Urey experiment. My question is, what do you think is the actual probability our atmosphere could be recreated on another planet, like artificially?
Like artificially, like I'm trying to understand.
I think I understand. I mean, if we catch
Okay.
people up on the Miller and Urey experiment, so
Yeah.
so Miller and Urey, two, were they both chemists? One may have been a biologist working at the University of Chicago. This is back in the late 50s, early 60s. They put a mixture of certain base ingredients that we expected to find on Earth. They put in what we think was the early atmosphere on Earth, and they put a spark across that air, which as an energy source. Then they went away and came back, and when they came back, they found amino acids formed spontaneously in that primordial soup, basically, that they were creating. And so, again, this is very terraforming like. So I think the
Yes.
question is, can we set something loose that will then create the atmosphere that we now know and love on Earth, but on another planet?
So there's a couple problems that my terraforming friends sometimes don't remember, and that's that Mars does not have a magnetic shield anymore. We don't have we don't have an electromagnetic. We don't have a dynamo anymore. So we don't have that electromagnetic radiation protection. So our atmosphere is being constantly stripped away. So I'm not 100% confident that we could do that, but there are a lot of concepts for how we'd have to basically build up the atmosphere and how we'd have to like get things in the atmosphere to really kind of to get some warmth and to basically get some more radiation. There's a bunch of different concepts out there.
So this amounts to geoengineering, and
it's geoengineering.
And you got engineering chops, so this should be right up your alley.
Yeah, I mean, from a theoretical standpoint, is it possible to? I don't know if we need to go all the way back to Miller-Urey. What we need to do is we need to basically kind of make a simulated greenhouse effect. We need to get something in there to kind of get a controlled runaway greenhouse effect where we get enough of an atmosphere in there, where we get enough heating from the sun into that atmosphere, where it generates heat and thickens up the atmosphere on Mars, and then we can actually have then we pump out some more oxygen and things like that. So it is possible.
We can get a space pipeline from all of our energy generating plants and pump all the CO2 to Mars.
There you go.
And then, but Mars already has CO2 in its atmosphere, but it would increase the concentration. And then, that's how you do that.
And then Elon Musk and Jeff Bezos can fight to see who controls the pipeline. That would be the rest of that. Can you explain to me what the plan is to deal with the radiation on Mars? Like, so let's say we can grow something that supports life. Mm-hmm. What do you do? Have you thought about, I assume you have, the effects of radiation on whatever you grow, and how do you protect that?
So the big thing that we look at is we look at habitat. We look at habitats. We look at building habitats, including like a Martian greenhouse, and those habitats would have some level of shielding to protect from the radiation, especially from things from the solar wind, GCRs, things like that. One of the things that they looked at, they're looking at building partial habitats. They're looking at like Martian. Mars has caves. They have possible lava tubes. They're looking at or places where we just bury, we use actually some of the Martian regolith and
hide.
Rock. To hide. To kind of use it to kind of shield from all that radiation. But basically, you just kind of part of that is you build that shielding into the plan. The other part is we look at how we look at studies about how much radiation do we really need to shield the greenhouse, like how much radiation before the plant it really does cause plants to grow in a way that's not healthy, and does it produce actual nutritious biomass and things like that. So that we can optimize how much shielding do we really need for the greenhouse versus like the hab where that humans are sleeping. If the greenhouse could take more radiation, we maybe don't make the greenhouses shielded, so those are some of the trades that we need to look at.
If I'm going to Mars, I'm bringing a satchel full of cheeseburgers. That's all. I'm sorry.
and potatoes grown in the right poop.
In the right poop. My own damn poop.
Your own poop. A fry later to fry your potatoes grown in my own damn poop. That would be That would be the advertisement on Mars. Potatoes grown in my own damn poop.
Well, and then you have to grow the soybean oils to like make the soybean oil for frying your potatoes too in your own poop.
Oh,
So
yeah.
Oh, yeah.
Oh, there you go.
It's just like it's your own poop cycle, right?
Now you're getting the vegans aroused with that old soybean oil stuff. Should we go on? Another one?
Give me like one more.
All right.
One more.
Colby Hyde. Hello, Dr. Tyson. Colby Hyde from Colorado. My question is.
Wait, Kenda, we can get two more if you answer this in half the time. So let's try.
Okay. Fair enough.
Okay, go.
Hello, Dr. Tyson. Colby Hyde from Colorado. My question is, what is the coolest part about being an astrobiologist, which I guess would be for Kenda? What is the coolest part?
Yeah, and Kenda, by the way, astrobiology is a field that has no data. Let me just be clear about that.
Well, if you're talking about you're talking about our ultimate, that's not true. We have ambiguous data from Viking. That's not true.
Oh, it's still ambiguous data.
Just say it depends on how you define data, Dr. Tyson, and then it just creates a big open-ended answer.
I just want to make it clear. There's an entire field of study out there that has the name of something it has yet to find.
Yeah, but here's what you sound like. My field of expertise has data and yours doesn't. Yes. That's what you sound like. You sound like a 6-year-old.
He's just jealous because we're getting all the funding right now. That's all.
I know.
They're totally getting all the funding.
What I love about astrobiology is I get to go all over the world and meet totally new crazy microbes and learn the extent of amazing things that life can figure out how to do. And I just think it's amazing that we don't even fully understand life here on Earth. And I think that's a fun part of my job.
I think you're being modest. I think the best part of your job is looking down your nose at anybody's garden and going, really? You call that a tomato? Really? Well, let me show you my tomato. Boom. I grew this using mouse feces and some French fries from McDonald's. Beat that, buddy. On Mars. I grew that on the Q line in Manhattan. Beat that. All right, one more?
Last one, real fast.
All right. I'm going to do the best with this name. It's Boyateb Badayu. Dear Mr. Doctors Neil and Kenda, this gentleman's Boyateb from Nice, south of France. What kind of interesting feature could we bring from a plant grown on Mars and brought back to Earth? Could it be genetically more resilient to low luminosity, for example?
Ooh, nice. So let me broaden that, and then you still have to answer it in half the time. Could studying life on Mars benefit life on Earth?
100%.
And give me your best way that could happen.
Because we're having climate change here. We're killing our soil here on Earth, and we're going to have to figure out how to, in order to have food security, we're going to have to figure out ways to kind of help soil grow, whether it's open air or if we have to make our own giant greenhouses where we basically process soil like we do on Mars to keep it healthy so we keep growing plants so we have food security.
What you're saying is if we can grow plants on Mars, nothing can stop us from growing plants anywhere on Earth.
We can keep ourselves growing plants on Earth.
Okay.
100%.
Right. Mm-hmm. Well, that's all the time we have for it. You did two within one question. Thank you. Two in each in half the time. Kenda, thanks for being back on StarTalk. It's been a delight to have you.
And Kenda, let me say, I think you're doing great work despite the fact that your area of expertise has no data. I think you do great work. Don't you let anybody undercut you, young lady. You're strong, you're powerful, your data lacking, but other than that, you're
Tell me I sound like a 6th grader. I know you are, but what am I? All right, Paul, good to have you, man.
Yeah, always fun.
This has been another installment of StarTalk Cosmic Queries, the poop edition.
Don't say dirt, whatever you do.
All right, I'm Neil deGrasse Tyson, as always, bidding you to keep looking up.